Hello students, welcome back to our video session. The last video session we have been discussing about Python functions. We are going to continue in the same chapter. We are going to see some additional topics from this chapter. What are the topics we are going to cover today is scope of variables, types of scope, built-in mathematical functions, composition in function, Python recursive function. Let us go into the slideshow. Scope. Of course, you might have come across this word in your Dev C++. Scope refers to accessibility of a variable. Where we can access this variable, how to use it, that we can call as scope. Scope of a variable refers to part of the program where it is accessible, where we can use it. Scope holds the current set of variables and their values. There are two types of scope: local scope, global scope. You are going to learn about the scope right now. First, you will see what is local scope. They define local scope like this: a variable declared inside the function's body or in the local scope is known as local variable. Let me share the PyCharm window here. Let me create a new file and typing here is 139.py. Right? In the last video session, you might have learned how to create a user-defined function and what is the syntax for declaring user-defined function. Of course, every user-defined function will start with a keyword name called def. We can pronounce as definition, or we can say defining a user-defined function. So def space name of the function. I type here as local3. So name of my user-defined function is local3, followed by parenthesis. Of course, I am not using any parameters for this user-defined function local3. It's an empty parenthesis followed by colon. Right? Like other languages what you have studied, for example, it may be C++ or Java. To create blocks, we use open curly brace and closing curly brace. But in Python, we do not use that curly brace, but Python uses indentation, spacing. Okay, the space indicates the current block of this function local3. So whatever you're going to type here, it is going to be the block of local3. Let me declare a variable here. I'm declaring the variable y. Y equal to 10. Then in the next line, print the value of y. At present, the function local3 contains only two statements, two sequence of statements, right? After that, you have to come out of that block of that function. Okay, you have to remove the space. That's it, nothing else. Now I'm going to call that function local3. Of course, function must be called if you want to execute it. What's the name of the function here? Local3. So when you call this function, local3 function will be executed. What are the two things or what are the two statements present in local3? It contains a variable y and the value assumed to y is 10, and it contains a statement print the value of y. So this is the block of local3, and this block of local3 is going to execute. Let me run this program. So you get the output 10. Okay. Here, y is called the local variable of this function local3 because you have defined inside this block. So a local variable will have its scope and its lifetime only within that block, right? If you try to call that local variable outside the block, for example, here I'm going to call the y outside the block of local3. I'm giving here print within bracket y. Definitely your Python will raise an error. Y is not defined because y is a local scope variable for this function local3, and that y can be accessed only within this function block. Y cannot be accessed outside the function block. Okay, wow. That's what they have said in the rules. A variable with local scope can be accessed only within the function or block that is created. When a variable is created inside the function or block, the variable becomes local to it. A local variable only exists while the function is executing. Of course, formal arguments, the arguments what you see in your main function are also called as local to function. Are you clear what I'm saying? These are the rules for declaring a local variable in a function block, right? The next one is global scope. Of course, a variable declared above all the functions or above all the blocks, we call that variable in what scope? Global scope variable, right? So a variable with global scope can be used anywhere in the program. It can be created by defining a variable outside the scope of any function or block. Okay, wow. Now let us declare a variable. I am declaring here as x equal to 5. Now, since this x is being declared above this function local3, this x becomes a global scope variable. Global scope variable can be accessed inside the function block like this. Print in bracket, I give x. Now take away this line. Okay, wow. Now try to execute. It prints 10 and 5. 10 is the value for your local variable y. 5 is the value for the global variable x. Global variable can even be accessed inside the function and outside the function. Now let me type print within bracket x. Now x is been accessed twice. X inside the function block, x outside the function block. We can access, yes, we can access because x is a global variable, global scope variable. So we can see the value of global scope variable printed twice on the output. Okay, wow. One more thing. If you are going to change the value of a global variable inside function block, you cannot do without the help of global keyword. Now I say like this, x equal to x plus 5. You may say x is a global variable, yes. We can access the value of global variable inside the block, but we cannot do any changes to global variable. If you want to do changes to the global variable, you have to use global keyword inside your function. Of course, this program will raise an error, right? Local variable x referenced before assignment, because x is not a local variable, x is a global variable. How to access the global variable inside your function? Now type here global, then x. In the next line, type x equal to x plus 5. Now you can access your global variable because you have used this global keyword to access x. Now you want to change the value of global variable. Yes, we can change it. When you try to execute this program, the program may produce you the value of global variable altered. Yeah, can you see here? 10, 10. Local value is 10. Of course, y value is 10. Previously, the value of global variable was 5. Now it has been altered to 10. Right? So rules for global variable. When we define a variable outside a function, it is global by default. You do not have to use global keyword. We use global keyword to read and write a global variable inside a function. Use of global keyword outside a function has no effect. So these are the things which you should be having in mind when you declare a global variable. A variable defined above your functions or blocks will behave like a global scope variable. Right? Can global variable and local variable can have the same name? Yes. Both global variable and local variable can have the same name. Here we can see the global variable name is x and the local variable name is x. Both are having same name. No issue of having same name for both global and local variable. The next topic, what we are going to cover is built-in and mathematical functions. In Python, we have some built-in functions. They are called as your library functions, which are already created and kept in your Python library. The first one is ABS. It stands for absolute. Okay, wow. What does this function do? Returns an absolute value of a number. The argument may be an integer or a floating point number. Next built-in function is ORD. What does this function do? Returns the ASCII value for the given Unicode character. Of course, you know what is ASCII mean by? American Standard Code for Information Interchange. Every keyboard character contains an ASCII value. What does this ORD function is going to do? You are going to give a character. For this current character, it is going to print the ASCII value. Let me show on the screen. Okay, wow. Let me declare a variable x equal to, I'm declaring here, x equal to minus 20. X equal to minus 20. Then, the next line, I type like this, print within open bracket the absolute value of x is, right, comma, abs within bracket. Use that variable name inside that function, abs x. Now try to run this program. You can see the value 20 on the screen. Okay, wow. What does it represent to us? Even if you pass a negative value, your absolute function can convert that negative to a positive value. Clear? Right. Let me declare a variable like this. Okay, wow. C equal to, within single quotes, capital A. Now I am going to use ORD function. What does this function do? You know it very clearly. Returns the ASCII value for the given Unicode character. Of course, the variable now name has been changed from X to C. Python is case sensitive, so type your variable name in lowercase letters. And we are going to check what is the ASCII value for this Unicode character capital A. Of course, we get an error here. We have to find out what's the mistake we have done. C equal to A. Oh, of course, I have not changed the function name here, ORD. I'm sorry. Try to run it. So the ASCII value of C is 65. Of course, the ASCII value of C is not 65. A is a character stored in your variable C. For this capital A, the ASCII value is 65. Okay, wow. Right. Then we have a function called CHR. Right. Now, in the place of A, I am going to use 65. Right. And your CHR, what does this function do? Returns the Unicode character for the given ASCII value. Returns the Unicode character for the given ASCII value. 65 is my ASCII value. For this ASCII value, what is the Unicode character? I am going to check out on the screen. Run this program. So for this 65, the ASCII value is A. Clear? Okay. Then the next function is bin. Okay. What does this function is capable of doing? One of your built-in function returns binary string prefixed with 0b. Okay, right? Let me declare a variable x and assume the value of x is 15. Okay, wow. Then print the binary value of x is. Of course, x is a decimal. X contains a integer value. It's a decimal value. I'm going to convert the decimal to binary. To convert a given decimal to binary, we use bin, bin. Okay, wow. Bin within bracket x. Of course, you know how to convert a given decimal to binary. If you convert this given decimal 15 to binary, I think this will be the answer for you. 111. Of course, before this 111, they are prefixing with 0b, indicating the number what you have printed here is a binary number. Binary number. Are you clear? Then so you have seen ABS, ORD, and bin. Then we are going to see about round. Okay, wow. Okay. Now, ROUND, round function. What does this round function do? Returns the nearest integer to its input. Let me declare a variable x. X equal to 17.9. Okay, wow. I type here print, open the bracket, within double quotes, the rounded value of x is, comma, just use your function round within bracket x. So if you say I'm going to round the value, it is going to show you 18. I think so. Let me see the screen. So the value x is been rounded. Returns the nearest integer to its input. The nearest integer of 17.9 is 18. Okay, wow. Then we have one more function called format. We'll see what is format. Okay. Returns the output based on the given format. See, we have seen bin. Bin function is used to convert the given integer to binary format. Likewise, you can use, in the place of bin, we can use format. Returns output based on the given format. Okay, wow. Let us see this on your PyCharm window. Okay, right. Let me delete this content. Right. X equal to 15. Let it be the same value. Right. Print, open the bracket, in double quotes, the value of x in binary, the value of x in binary, comma, format, open the bracket, x, comma, within single quotes, I am giving b. Okay, x is my variable. I'm asking format to display the value of x in binary format. So your format function can convert the given integer to a binary format. See, format inbuilt function can be used as a replace for your bin. Clear? Right. We'll push on to next. You have seen round. Of course, power is one of your mathematical function. Right? What does this function do? Returns computation of a raised to the power of b. Okay, very simple function. So you can, from the example, you can see we have a base and we have a power. So 5 is your base, 2 is your power. So 5 square is 20. Now we are going to see mathematical functions. Up to this, what you have seen is your built-in functions. Right? Now you are going to see mathematical functions. The first one is floor, F-L-O-O-R. See the definition of your floor. Returns the largest integer less than or equal to x. So if I am passing a value, that value floor is going to return as a largest integer less than or equal to the variable x what you have defined. Let me share your PyCharm window. Let me delete this content what I have typed. Let me type x equal to 25, x equal to 25.5. So I'm giving x equal to 25.5. Before this, make sure if you are going to use your mathematical function, you have to import a module. The module name is called math. It's a math module which can be used for all your mathematical functions. So import space math. Right? Then I declare a variable x equal to 25.5. Then in the next line, print within bracket. Okay, I just give math dot floor within bracket x. Can you guess what will be the value returned by this print statement? I think it will be 25. Yes. Why? I said you returns the largest integer less than or equal to x. Floor can return the largest integer which is less than or equal to x. Less than or equal to x means 25 is less and it is equal to x. It cannot return you 26. Right? Next one is ceil. C-E-I-L. Right? What does your ceil function do? Returns the smallest integer greater than or equal to x. Of course, we can see the value output as 26 here. Correct? When I use ceil. Why? Because ceil function returns the smallest integer greater than or equal to x. The value 25 is assumed to x, so it says it can be greater than or equal to x. So 25.5 can be converted to 26 when you use ceil. Then SQRT, it stands for square root. To find a square root of a given number. Square root of 49 is 7.0. Okay, wow. Then you are going to learn what is composition in functions. The value returned by a function may be used as an argument for another function in a nested manner. This is called composition, right? That is, output of one function may be passed as an input to another function. Output of one function may be passed as an input to another function. They call that as composition in functions. Right? Let me share your PyCharm window. Right? Here we can see I'm using my input function to get an arithmetic expression from the user. That arithmetic expression will be evaluated by evaluate function. It evaluates a value and stores in N1. Let me run this program. It is asking the user to input a expression. So I'm giving 10 plus 30. This value will be evaluated by evaluate function and store the result 40 in N1. Of course, you know input function in Python will accept anything in string. That string is evaluated and stored as a numeric value in N1 by evaluate function. But the simple logic reason is very clear here. Composition is used for what reason? The output of one function may be used as the input of another function. Okay, right? The next topic, what you are going to learn is recursive function. A function which calls itself is known as recursive function. Recursive function more or less works like a loop, but sometimes it makes more sense to use recursion than loop. Better to use recursion than loop. How you have a end condition for a loop, for recursive also we have an end condition that we call as base condition. Now look out this program here, right? They have declared a user-defined function, fact. Okay, va? Okay. Now, inside your fact, they have used your if condition. And they check the value of n. If the value of n is equal to 0, return 1. Else, return n into fact of n minus 1. What is recursive? Function which calls itself is called recursive. When does this recursive function will come to end? Definitely this recursive function should have a base condition. When the base condition is satisfied, the recursive function may come to an end. Right? And I pass two values for this recursive function. One is fact of 0 and one is fact of 5. When I pass fact of 0, it returns 1. When I pass fact of 5, it returns 120. Let me show this on the screen how it works. Let me take the value of n as 5. So that will be passed down to the user-defined function. So n equal to 0, condition is false. So it comes to else part. In else part, we are given like this. N into fact of n minus 1. What's the current value of n? 5. Into fact. What is fact? Your user-defined function. Of course, now this function is a recursive function in this program. In the bracket, 5 minus 1. So, Every time this fact is going to be called, when it's going to be called, it is going to subtract the current value. At present, it is going to subtract 5 minus 1. It is going to send 4 to that function fact. It is going to check 4 equal to 0. No, it will come to else. Now, 5 into 4 into fact of 4 minus 1 is going to return 3 to your function. It is going to check here. 3 is equal to 0. No. N into fact of n minus 1. So 5 into 4 into 3 into fact of 3 minus 1. The value now is been 2, the past year. 2 equal to 0. No. Once again, it come to else part. Now it is be 5 into 4 into 3 into 2. Fact of 1. Your user defined function will get the value 1. 1 is equal to 0. No. So you'll come to else part and execute here. N into fact of n minus 1. So 2 minus 1 is 1. 1 equal to 0? No. Once again, we'll come back here. N into fact of n minus 1. 1 minus 1 will change to 0. At the fifth step, it will change to 0. When you pass 0 in your user defined function, n equal to 0. 0 is equal to 0. Condition is true. If the condition is true, what we have said, return 1. Where does this 1 will come? To the last calling of the fact. The last calling means it will come here. So what's the value here? Fact of 0 here. When does it return 1? When the value of fact is being given as 0 here, it will return 1. So it ends here. So your recursive function will do the process from the reverse order. So 1 into 1 is 1, 1 into 2 is 2, 2 into 3 is 6, 6 into 4 is 24, 24 into 5 is 120. Are you clear? Right? Let me give you some more built-in functions. Of course, one is type. Okay, well, already I've seen it, so I just want to recall for you. So type. Let me declare a variable. I'm sorry. X equal to 30. Print type within bracket X. So what type of variable X is we are going to find? X is of type integer, right? Then print ID of X. It is going to print memory address of X. This is the memory address of X. Then, of course, you'll be learning very deeply about sequence data type in Python in lesson number 9. Here I'm just going to show you what is list. Of course, your list can be compared to your array. My list equal to, your list elements should be given within square brackets. I give here 10, 20, 30, 40. So these are the list elements and my list name is my list. So print within bracket my list of my, I'm sorry, just type here like this. Print minimum. Min is a function. Minimum of my list. Of course, minimum value of this list is 10. Will accept that? Yes. Then max. Maximum value of this list. Of course, it is 40. Then sum. Add all the values in your list. Of course, when you add all the values, the value will be 100. Yes? Okay. Right? So that's all in this chapter. We have covered all the topics. We have covered types of scope. We have covered your built-in and mathematical functions. We have covered your composition in functions, and we have covered recursive function. Keep in mind, when does the recursive function will end? When it meets the base condition. N is equal to 0 is the base condition in recursive. When it meets it, the function of recursive will come to end. Right? Okay. This is your assignment question. Please go through this assignment questions. Try to prepare your classworks from your home. I hope you will not waste your time. Time is very precious. Right? Try to prepare this assignment from your home. We'll meet in the next video session. Thank you.